This is an example of a prediction profiler used for optimizing your system. Some things to note here are that on the y-axis you have human toxicity and environmental impact, which is for us measured as CO2 emissions. We have energy consumption in kilowatts, the cost in dollars, the viability of a process, which is percent of parts that have passed quality control inspection, and this is the desirability or the combination of what we want these systems to produce. We have chemical 1, 2, 3, 4. On the right we have how we've set our desirability. For example, we've said that we want the human toxicity to be we want it to most be 200. We want it to least be 50. So it's trending towards the higher. It tries to optimize the system to give whatever the furthest right little square here is. Environmental impact, we said we want this to be lower. We want the energy consumption to be lower, we want the cost to be lower, and we want the parts that pass QC to be higher. These purple triangles describe the slope, how steep the slope is, or how responsive this particular output is to this particular input here. For example, this one says that the energy consumption goes up with chemical 3. It actually seems to go down with chemical 2. So we look at that. We can turn those are called sensitivity indicators. We can turn those off or on. And we optimize the system. This system says that if we use a mixture of 46% chemical 1, 54% chemical 3, we'll have the best chance of getting what we want, which is 50-50, which is not really good. And we expect to get these values in red that you read here. So, but if let's say we couldn't do a mixture, we could only do all of chemical 1 or all of chemical 3, well then we just say, okay, well it's all of chemical 1, let's just push this up, and you see how chemical 3 is going down. And let's see here, well then what would we get? We would get actually better. The computer didn't find this. We get 57% of what we want. That's how it changes the profile. Now watch me scoot this kind of up and down here. You can see how these slopes, watch the slope right here of the energy consumption go up and down as I change the amount of the chemical 1 that I have. And look at, if I add chemical 4, watch what happens to everything. Our desirability goes down. So it's not really good to add chemical 4. We don't really want a lot of that. But you can see the system is sort of living here based on our data that we collected. What if I changed my mind and I wanted a different sort of optimization? Well, you can drag these optimization profiles here on the right around to say, okay, I want a different value of human toxicity. I want to be a maximum here at a different point. You can sort of make these, imagine these like sideways Gaussians. I could change this, change the desirabilities, and I can change the importance here. I could change this, and then I can re-optimize the system. I can go to the prediction profiler and I can say maximize desirability, and it gives me a different answer. It gives me different, now it includes some chemical too. If I just say, oh well, these are I want the desirability of the human toxicity to be around 100, and 200 is not better. Well, it's not really what we want the system to say, but if that were the case, we'd say, oh, we'd add some of chemical 2 into the system, and you can see how the profile changes there. You can also double click here and you can give things different importances. So I've said here's where I want these guys to be, and you can just type it in instead of saying what you want. Instead of drawing it here, you could just type this in, and I can set the importance to 5 for human toxicity. Let's say the human toxicity is now the most important thing. I'm going to print that to 10, and I'm going to make the other ones really low importance. And let's see what the optimization profile tells us then. I don't care about quality, I don't care anything but human toxicity, and I want that level to be really, really high. And I don't care about the other ones. And then if I go back here and go to maximize desirability again, well, I get a different profile. It says, well, in that case, just use basically all chemical 1 if nothing else matters to you. And conversely, if I were to say, okay, well, the only thing that matters to me is the cost. Let's change the cost here. I'll double click that and say that's going to be 10. and human toxicity is just going to be 1, then now if I go through and I maximize desirability, it gives me a different profile. It says, well, you want half a chemical 1 and half a chemical 2. So that's how this can help you to share this information with others and to use this profiling tool to communicate your results with stakeholders and to optimize your system.